So hi guys, we are back with another combined mathematics video. So in this, of course, we are going to discuss the past paper questions related to the relative acceleration lesson, right? And then as the first question, I have chosen the 2015 problem, right? So we will see what it is. So actually they have given a long passage here, right? So like you can read it up to this point, of course. It's just the explanation uh, of the question, right? So like what simply they're saying that there is a wedge placed on a smooth horizontal table, right? So if since it is placed on a smooth horizontal table, there's no friction, and then two masses of P and Q of the mass simple M is placed in this way, which is connected to each other using an inextensible string, right? Using an inextensible string, and then thereafter they are saying another particle S is placed, which is of mass m over 2 on this AC surface, right? So yeah, and then they're saying write down the equations of motions for particle P. You need to write the equations for particle P along ED, Q along DB, and S along AC. Further write down equation for the whole system along BC. So this, of course, they have told where you need to apply the equations in, right? So yeah. First of all, when you do a relative acceleration problem, guys, right? What you need to do is you need to mark all the possible forces. First of all, as the first step, you need to mark all the possible forces. So let us do that. Let us mark all the possible forces here, right? So I took the same diagram. So they have told, guys, this is of weight capital mg, right? And then they have also told this is simple mg, this is also simple mg, right? And then this they have told m over 2g, right? M over 2g. And let us mark next the reactions. This is, let's assume, rs, right? And this is rs as well. So let us assume this is rp, right? So this is also rp, always perpendicular to the surface, right? rq, rq, and then there's also once again another contact surface. Let us mark this as S. We do not have to mark the forces on the ground, right? We are not going to deal with it. And then finally we need to mark the tensions as well, isn't it? There's a tension. This is T, and then this is T as well, right? Okay. So what else now? Now you have marked all the possible forces, right? You have marked all the possible forces. Next, what you need to do is you need to mark the accelerations of the particles, right? So you need to mark the accelerations of the particles, right? Let us assume the accelerations, right? So we need to mark the accelerations. So I'm gonna mark the acceleration of the complete wedge. I'm going to assume the wedge is moving in this direction with an acceleration a. I'm going to assume the wedge is moving in this direction with an acceleration a. So that acceleration of the wedge relative to Earth is in this direction a. Next, I'll consider the particle S. I'll assume the S is moving downwards with a's velocity. I'll assume the particle S moves downwards along the plane with a's. You do not have to exactly know the directions, guys, right? So you can randomly mark. It doesn't matter. If your selection of the direction is correct, you will get the answers for these accelerations as positive. If the directions that you selected is incorrect, then you will get the accelerations as negative, right? So O is equal to in the downward direction A is, right? Fine. So acceleration of S relative to what? Is it relative to Earth? Is it moving relative to Earth? No, it's on the wedge, right? So it's moving relative to the wedge. You need to understand. So it's moving relative to the wedge. In which direction? Downwards. This is 90. Sorry, this is alpha. This is 90. This is what? 90 minus alpha, right? So it's moving with 90 minus alpha in this direction with A is right. Okay, so we need to find the acceleration of S relative to Earth as well, right? So that is acceleration of S relative to M, right? You do not have to write the equations and all, but still, if you write it, it's better. Acceleration of S relative to the wedge plus acceleration of the wedge relative to Earth, right? So acceleration of S relative to the wedge is what? In this direction is acceleration of M relative to Earth is in this direction A, right? Next, let us consider the particle P. The particle P, guys, it will move, let us assume in this direction, right? So yeah, this guy is going to move, let's assume, downwards with A dash. If Q moves downwards with A dash, P will also move forward with A dash. That's obvious. Why? Because both the P and Q particles are connected together, isn't it? Both the P and Q are connected together, right? So acceleration of P relative to the wedge, relative to the wedge, right? Acceleration of P relative to the wedge is in this direction A dash. Acceleration of Q, because both these particles are on the wedge, right? So they are going to move relative to the wedge. Acceleration of Q relative to the wedge is in this direction, alpha direction, A dash, right? So now you can write the acceleration of P relative to Earth as well. Acceleration of P relative to Earth is, you can write the equation in the same way. I'm not gonna rewrite it, right? A dash and acceleration of A, okay, A. Acceleration of Q relative to Earth, you can write in the same way. This direction A, and it's moving in this direction, alpha A dash, right? So guys, we have all the accelerations of the wedge relative to Earth, acceleration of the S relative to Earth, acceleration of P relative to Earth, acceleration of Q relative to Earth. So these four are there. So now we can easily go for the problem, right? So let us see what they are saying. Write down the equations of motion of particle P along ED. We need to write it along ED for P ED along ED, right? Right. For P along ED, we need to apply. For P along ED, we need to apply F equals MA, right? F equals MA in this direction. So the force acting on P in the horizontal direction is T, right? Isn't it? It's T. What else? What else? Is there any other force acting on P in the horizontal direction? Not at all, right? So therefore, that is equal to, its mass is what? Mass is simple M. What is the acceleration of P relative to Earth in this direction? Acceleration of P relative to Earth in this direction. A dash plus A. Both are in the same direction. So A dash plus A. This is the first equation, right? What do they ask next? For the particle Q along dB. For the particle Q along dB. Okay, along dB. For particle Q along dB. F equals MA along dB, right? So what is the force acting on Q in this direction? Mg. So if this is Mg, guys, right? If this is Mg, you know this is alpha, and this is alpha, this is alpha. Mg sine alpha. The component of the weight acting along the dB direction is Mg sine alpha. This is perpendicular, R is perpendicular, T is in the opposite direction. So Mg sine alpha minus T. So simply, Mg sine alpha minus T is equal to the mass of Q is M. What is the acceleration of Q in this direction relative to Earth in this direction? A dash. This is in the horizontal direction. So what is the component of the acceleration along this direction? A cos alpha. A cos alpha. A cos alpha plus A cos alpha. Second one, right? So next what do they ask? Oh, particle S along AC. Particle S along AC. So what is the force acting on S along AC direction? Particle force acting along S in this direction, what is it? It's simply particle S along AC direction, right? AC is this 90 minus alpha direction, right? For here you need to apply F equals ma. So what's the force acting on the particle S along this direction? M2G, this is 90 minus alpha, this is 90 minus alpha, this is alpha then, right? This is 90 minus alpha. If this is 90 minus alpha, this is 90 minus alpha, therefore this is alpha. M2G cos alpha, M2G cos alpha, that is the only force acting along AC. M over 2G cos alpha is equal to, what is the mass? Simple M. What's the acceleration? Acceleration of S relative to Earth is what? Acceleration of S relative to Earth in this direction is AS. This is in this direction. As we know, now this is alpha. This is 90 minus alpha. This is 90 minus alpha. This is alpha. So sine alpha, A sine alpha is going in this direction upwards. So in the downward direction, you have AS, but minus A sine alpha, isn't it? See, once again, the acceleration of S relative to Earth in this direction is AS. Okay, AS is there. A is in this direction. We need to find the acceleration along this direction. So this is alpha. This is 90 minus alpha. This is 90 minus alpha. This is alpha. So you have to resolve it. Take the sine component. A sine alpha is acting along upwards. So it should be minus, right? Right. So this is the third equation. So what else? And then they are asking, write down the equation for the of the motion for the whole system BC. You need to write down the equation of the motion for the whole system BC. For the whole system BC. For the complete system along BC. BC. Right? Along BC. Right. System F equals ma along BC. Right? What is the acceleration? What is the horizontal acceleration of the system? This is these two cancels. This RS cancel. RQ cancels when you consider the system. S perpendicular force mg, capital M. All these are perpendicular forces. There is no horizontal force. There is no resultant horizontal force. Therefore, if you consider the system, the resultant horizontal force is going to be 0. What is the total mass of the object? The total mass of the object is the mass of the wedge is capital M, right? So when you apply for C systems, you need to separately apply MA products to each and every object, right? So I'll initially consider the wedge. So if I consider the wedge, the mass is capital M. The acceleration of the wedge relative to Earth is A in this direction. Next I will consider P, right? P. Okay, the mass of P is M. Acceleration of P relative to Earth in this direction is A dash plus A. A dash plus A. Next, let us go for Q. Q, acceleration of Q relative to Earth in this direction is A plus A dash cos alpha. A plus A dash cos alpha plus, if you consider Q, acceleration of Q relative to, yeah, that's fine. We have done that. Acceleration of S relative to Earth is, in this direction is A. This is 90 minus alpha. This is 90 minus alpha. And this is 90 minus alpha. This is alpha. Then. This is alpha. So A minus A sine alpha. A sine alpha. A minus A sine alpha. mass is mass of S is m over 2. Acceleration in this direction is a minus a is sine alpha, right? So this is the fourth equation. These are all the equations that they are asking, guys, right? And hence, out of these four equations, you need to solve and you have to find the acceleration of the wedge, right? So actually, you need to solve all these 1, 2, 3, and 4. There are four equations, actually four unknowns. A dash unknown, A is unknown, A S is unknown, and T is unknown. So four equations, four unknowns. You'll have to somehow solve simultaneous equation, and you will have to find the acceleration for A, and you have to show that it is this, right? It's not very complicated, but it will take some time for the simplification, guys, but it doesn't matter. You know why? This is the complete problem of 12th one, right? There's no B part for this. There's no B part. The complete 12th question is this, I guess, right? So therefore, as I remember, I'm not quite sure. Check that once again. Anyways, so this is one complete question as I remember. So therefore, uh, so giving some higher time for this, it doesn't matter, right? Right. Okay. So you can simplify and get the answer for the wedge, I guess. It's fine. So let us move on to